Welcome back, Algebra students, for the last video of week 4. Today, we're doing solving multi-step equations. A multi-step equation, what is that? Well, it's an equation that requires more than one step to solve. So, you might have remembered a equation that looked kind of like this, 2x equals 20. Well, what if we add a minus 10? Or was it x minus 10 equals 20? What if we add the 2 in front of the x? Give it a coefficient. Well, suddenly, we cannot solve this in one step anymore, right? So last time, all we had to do was just add 10 to both sides, and whoop-de-doo, we were done, right? But we're not done this time. Now we have to do another thing. Goodness gracious, x equals 15. Here's another example of a two-step equation. Here, we have to first multiply by negative 2. Then we get x plus 3 equals negative 20. Subtract 3 to both sides, x equals negative 23. I hope I did my math correctly there and I did not embarrass myself. Let's take a look at an example. Mr. Payne is buying a new pair of shoes. That man, he loves his shoes. They are on sale for 2/3 of the original price. After he uses a $250 gift certificate, the total cost before taxes is $1,825. For those of you that don't know what a gift certificate is this piece of paper that allows you to take money off of the buying price for something. So if you have something that costs $500, for example, and you have a gift certificate for $100, then you only have to pay $400. It's a little bit like a coupon, but it's something that someone has bought for you. Someone has already paid that money, basically. So anyway, what was the original price of the shoes? Write an equation and solve. Okay, let's do it. Well, let's not use O because O is a letter that obviously looks like 0. So we try to avoid O in handwriting unless there's some way that you can make sure that your O's are definitely O's, like, making it cursive or something. But then this kind of looks like, what is that, theta? So I wouldn't really even do that personally. So let's just go with T for total cost instead of original cost. So T is the original cost. Original cost. And the original cost was reduced by 2/3, right? Because they're on sale for 2/3 of the original price. So 2/3 of T. And then he used an additional $250 gift certificate, right? So we took an additional $250 off. And that gave us our final cost to Mr. Payne, and that is $1,850. So how do we find the original cost? Well, we can just work backwards, right? Through all of these discounts. We can add the $250 back on. $2,100. 2/3 T equals 2,300. Then we multiply by the inverse. Oops, that's supposed to be a 2. And then T equals 6,300 over 2, which is, what is that, 3,150? Yeah, 3,150. So the shoes were originally $3,150. But he paid only $1,850. What a good deal. A thrifty spender. Okay, let's look at some vocabulary words. Consecutive integer. This is an important concept in algebra. It comes up a lot, especially when you're talking about patterns. Consecutive integers are integers that are in counting order. For example, 1, 2, 3, 4. These are consecutive integers. And you might have noticed that in a table or an ordered pair, the x might go up by consecutive integers. And one way to say this is n plus 1. I'm sorry, n plus 1, n plus 2, n plus 3. So n is your first integer in your counting order, and then every time you're adding by 1. This way we can always be talking about whatever number we're on in relation to one original variable. Consecutive even or odd integers are integers where the first number is even or the first number is odd, and then we add 2 to each, right? So this is like 2, 4, 6, 8, and the odd are like 1, 3, 5, 7. Hopefully you know the odd consecutive integers pretty well now, because these are the ones that our homework problems usually are. So, number 3, the study of numbers and the relationship between them. That's number 3. When are we going to need to know that? Let's find out. For example, write an equation for the following problem. Then solve the equation and answer the problem. Okie dokie. Find 3 consecutive odd integers. 3 consecutive odd integers with a sum of negative 51. Well, how can we find that? We could, of course, guess and check, but there's a much easier way. We can say that the number n is equal to the smallest odd integer, right? We might even just say consecutive, but I'm not writing it in there. Then the next number, whatever that's going to be, is going to be n plus 2, right? And then the next number is going to be n plus 4. So these numbers together are going to sum up to negative 51. So let's write that. n plus 1, n plus 2, plus n plus 4 equals negative 51. So there's 3 n's here, 3n, and then we have a 2 and a 4, and we can just do this in any order we want, right? Because of the communicative and associative properties of addition. We can change the grouping, we can change the order, so on and so forth, equals negative 51. Subtract both sides by 6. This is our equivalence. 3n equals negative 57. Then we just divide both 3 by 3 on both sides. And I'll come back up here. N equals, what is that? Negative 19? Negative 19. So what's the next number then? What's negative 19 plus 2? That would be negative 17. What's negative 19 plus 4? That's negative 15. So our 3 consecutive integers are negative 19, negative 17, negative 15. And just in case you wanted to check your answer, you could, of course, just add them together. And I'll just give you a hint. It's going to be negative 51. Boom. Next example, we're basically looking at the same thing. I just want to make sure you really get this, so we're just going to do it again. Write an equation for the following problem. Find 3 consecutive integers with a sum of 21. So here we go again. N equals our smallest integer. And it's important that you do this step here where you define your variables, because if you do not define your variables, I will automatically deduct points from any kind of summative that you do, especially if it says something like write an equation. You cannot write an equation that has variables in it where you do not define the variables, even if it's like obvious to me. You know, like if you're talking about price and you use P, or you're talking about length and you use L, or something like that. Yeah, always need to define your variables. So anyway, the next consecutive integer is going to be n plus 1, and then the next one is going to be n plus 2. So n plus 1 plus n plus 2 equals 21. Here again, we have 3 n's. And then we have plus 3 equals 21 minus 3. 3n equals 18 divided by 3. N equals 6. That means the next number is going to be 7. The next number is going to be 8. Here are 3 consecutive numbers. 7 plus 8 plus 6. Does that equal 21? Yes, it does. We are amazing. Okay. Goodbye. Oops. Goodbye.